Okay, we want to look at some strategies for solving problems. Now, the text quotes George Polya's strategies, and he was a great man and had a lot of really good ideas about what constitutes problem solving and ways to enhance it. Now, I'm going to solve some problems and point out, I'll solve some problems on another clip, but on this clip I'll just kind of outline some of the things that Polya said. First, understand the problem. You got to read the problem, you got to play around with it, and again, I'm not going to talk about how you do that. I'm going to do that, and then I'll point out that maybe that's what we're doing in the process. Okay, then plan. Come up with a plan for solving the problem. You might not have a good plan the first time, but come up with a plan anyway. After you've made one plan, it's easy to go back sometimes and make another plan. Then do it. Now, I think in the book it says carry out the plan. You can read Polya's strategies as the text states them. I have no problem with the way the text states them, but I'm not going to state them in the same way. Hopefully, between the way I state it and the way the text states it, you'll get the true meaning of the idea of problem-solving strategies. Okay, then, step back. Think about it and check it. Check and see if it really works, and see if it fits with your understanding. See if your plan really worked to obtain what you were trying to get, to solve the actual problem. Now, there's some suggested strategies, and these are good strategies. We'll use some of them more than others in this course, and you'll just see as we go. Tables, charts, graphs. If you can make a table, a chart, or a graph of a problem, that goes a long way toward giving you something to grab onto, giving you something you can actually look at, where you can look for patterns, where you can look for indications of how you might solve the problem. Okay? And then, look for patterns. We've already seen several patterns. Simplify. Now, what the book says is solve a simpler problem. If you're trying to find the 87th pentagonal number, start by finding the first and the second and the third. Look for a pattern. Look for the pattern in the simplest instances you can find. Okay, sketch. Which kind of goes in with tables, charts, and graphs, but a sketch could represent more than a table, chart, or something different than you can represent with a table or a chart or a graph. Inductive reasoning, I'm not going to mention that. That's almost implicit in looking for patterns. An equation. If you can write an equation, this equals this, where you've got an unknown that represents what you're trying to find, that's a good idea. A formula. Although you got to be real careful with formulas, because if you don't really understand the situation, you run the risk of misapplying a formula. Okay, working backward. I'm really kind of copying down the list here, but making some of my own comments on the list. You can read the textbook's comments. But if you work backward, if you start from the end and work backward toward the beginning, we'll see instances of that. Guess and check. Trial and error. That's an R. Common sense. Sometimes common sense can simplify something that looks very complicated. If you just think about what's going on and use what you know, sometimes a very complicated looking problem has a very simple answer, and we'll see instances of that. And look for a catch. Okay? Sometimes the answer looks really easy. It looks like, well, that's obvious. A lot of times there's some kind of a little catch in the problem that's going to throw you off if you try to do what seems like the most obvious thing.